So we move on to guided practice 3A and 3B on page 134. And 3A gives us this function, h of x equals x minus 6 over x plus 2. We're going to work through that same process. Let me draw my coordinate plane. Give myself a scale here. And first thing we're looking for is the domain. Again, everything that's going to make the denominator 0 cannot be a part of our domain, so our domain very clearly be all real numbers except -2. All right, which also means that my vertical asymptote is going to be at x equals -2. My horizontal asymptote in this instance, again, I'll look to the degree of the numerator and the degree of the denominator. The degree of the numerator is 1. The degree of the denominator is 1. So I take the ratio of the leading coefficients, all right? Not the ratio of the degrees, because that's always going to be 1, but in this case it happens to be that way anyway, where my leading coefficient up top is 1, my coefficient to my bottom is 1. So I end up with y equals 1 over 1, or just 1 as my horizontal asymptote, okay? So I can plot those. My vertical at -2 and my horizontal at y equals 1. And then we can look for our intercepts, which are not terribly difficult to find here. My x-intercept will be wherever the numerator is equal to 0, and that'll just be at 6. On the x-axis, right here. And my y-intercept is going to be plugging in 0 for x, or -6 over 2, which is -3. And puts that right here. Okay. I don't really need to plug in any more points over here to see what's going on. I can tell that this is going to kind of be something like this. And I actually know, based on the nature of these graphs, that I'm going to mirror it either up here or down here. Let's plug in 1 point to the left of -2 just to see exactly what's going on. And if you can't quite picture that, you can always plug in more points. But if I plug in -2, can't. Remember, we had to plug in something less than -2. Let's go -3, and that's going to give my denominator to be -1, which is going to help. So I get -3. If I plug that in, I get -9 over -1, which is just 9. And that's going to be, that's 6, 7, 8, 9. That'll be right here. And so I can kind of tell that we're going to kind of take this similar shape there now. Again, because of the nature of asymptotes and because we've seen this type of function before. Let's move on to 3B. To a new page. If you need to pause it and look back or look back at it at a later time, again, these are all published to YouTube. So you can look it up whenever you want. 3B gives us another function in which the degree of the numerator is equal to the degree of the denominator, but I get h of x again equals x squared minus 4 over 5x squared minus 5, yep. My coordinate plane, go 8 in each direction. And I'll start finding the information that I have. My domain is going to be, again, found from the x values that make the denominator equal 0, I know that I'm going to exclude those from the domain. So if I add 5 to both sides, divide by 5, I can see that when I square root both sides here, remember I have to add my plus or minus. So my domain is actually going to be all real numbers except -1 and 1. Which also means you can expect vertical asymptotes at both of those. Right? X equals -1 and x equals 1. Since the degree of my numerator is once again equal to the degree of my denominator, 2 and 2, I get a horizontal asymptote at the ratio of the leading coefficients. The ratio of my numerator, or the leading coefficient of my numerator is 1. The leading coefficient of my denominator is 5. So I get a horizontal asymptote of y equals 1/5, which is very close to the x-axis, but not quite there. So if we plot all those points, and end up with something very skinny in the middle of this graph. But again, this is going to be really close, but not quite on the x-axis. Okay, now we can find some intercepts. X-intercepts are going to happen whether numerator is equal to 0. So if I set the numerator equal to 0, x squared minus 4 equals 0, I'm going to get plus or minus 2, right? Add 4 to both sides. Take the square root of both sides, get plus or minus 2. And that's going to be here, +2, and here, -2. Again, we can kind of see which shape those things are going to take. Based on those zeros, again, you can plug in more points. You might want to plug in something less than -2, or something in between -1 and -2, just for the sake of time and these videos. I'm going to make an assumption there that that's how this is going to look. And then I also want to plug in a number in between -1 and 1, but I'm going to actually get that from the y-intercept. Remember what's going to happen, or how am I going to get my y-intercept? I'm going to get my y-intercept by just plugging in 0. So I'm going to get -4 over -5, which is just equal to 4 over 5, or 0.8. And that's going to give me something like right here. And I also know that it's not going to cross the x-axis at all. So again, I can kind of assume that we're going to have a kind of parabolic shape right here. Again, tough to make that assumption, but in the interest of time, I'll give you that graph if you wanted to plug in like -1/2 and 1/2 to show you that, or any number as you get closer to 1 from the right and -1 from the left and -1 from the right. Again, plug in as many points or as few points as you need to see what the graph does. Moving on to 4A and 4B. Now we get into some slant asymptotes here. Finally, before A, it's going to give us another h of x that is equal to x squared plus 3x minus 3 over x plus 4, and these are going to take a little bit longer. So I'll probably get through one in this video and have to make another one for 4B. Nothing wrong with that. Draw my coordinate plane. So I've got my x and y axes. Make 8 in each direction. Again, it's a lot easier to do on graph paper. But anyway, here we go. We can see that our domain pretty clearly is going to be all real numbers except -4, right? which would lead us to believe that there's a vertical asymptote at the line x equals -4. Which looks like that. Horizontal asymptote. There's not going to be one, right? The degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote, but I can assume that there's a slant asymptote because the degree of the numerator is exactly one greater than the degree of the denominator. So I'm going to find the equation of that slant asymptote. Remember, it's going to be in the form of a line, so y equals mx plus b form, but I find that by just performing this long division. So x squared plus 3x minus 3 divided by x plus 4. And I get just an x here because x times x gives me that x squared. I get x squared plus 4x. Reminder that we're subtracting here, so we've got to flip our signs. To get negative x minus 3 here, to get negative x from x, I just have to multiply by -1. To get negative x minus 4, flip my signs, and I can get a remainder of 1. Give me plus 1 over my original denominator. If you recall, the slant asymptote, because as x's get really bigger, or really big in either direction, approaches positive or negative infinity, this term tends to go away, so we get y equals x minus 1. We can ignore the remainder when dealing with slant asymptotes. You also could have done this using synthetic division. I'll do that for the next one, just to show you kind of how to do that again. So we've got our slant asymptote, and we can graph that line by just using the slope-intercept form. I know my y-intercept is going to be on there, and my slope is, because this is 1, it's going to be 1 over 1, so I'll be up 1 over 1. I know that I've got this slope of positive 1. So either up 1 to the right 1 or down 1 to the left 1, and I can graph that line. Okay, another tricky part of this question is the fact that the numerator is not factorable. Okay, so when we go to find our x-intercept, I set this equal to 0, and I can't factor it because there are no numbers that multiply to give me -3 that add to give me +3. But I can solve any quadratic using this quadratic formula, and so let's do that. I get -3 plus or minus the square root of b squared minus 4ac. Well, -4 times -3 times 1 is going to give me plus 12 all over 2. Okay, and that's going to give me my 2 x-intercepts. Those happen to be somewhere around 0.8 and 3.8. They'll do that math for me. I just kind of got those answers out of the book, again, for the sake of time. But try to work those out and simplify. And that's just going to happen about -3.8, sorry. That's why you have to check those things. So we get really close here and really close here. If I plugged in a point around here, I can kind of tell that, again, because of what I know about asymptotes, I'm going to get this kind of shape here. If we plug it in a point like -5, we would get something just barely below here. And again, it ends up looking something like this. All right, one of the more funky looking graphs that we've seen, but this is what your final answer should look like. If you need more clarification on that, try to plug in some other numbers. If you can't get it, you can ask me about it on Monday, and we can kind of rework this one out. All right, but that's about enough time for this video. I will post another one for 4B, and then the work that you're going to do today.